Hey 30-1s, here is our lesson on converting between radian measure and degrees. So I want you to think of this as the same as switching from imperial to metric. And I want you to think of degrees as imperial, and I want you to think of radians as metric or scientific notation. So here we go. If you watched the last video about the history of math, which I really hope you did, what we talked about in that lesson was that trig is really about circles. It's not a great circle, but you get the idea. And that the ancient Babylonians were brilliant, and they said the radius of this circle is 1. Okay, so what can we do with this information? Really important information we have here. Well, what do we know? Well, I'm going to go back to something I do know that they taught me way back when I was a little guy. I learned when I was a little guy that the circumference of a circle is 2 pi r. Cool. But I don't see anything about degrees in there. Actually, if we think about our other formulas for circles, degrees really, my friends, aren't that useful, are they? So this is why we're going to do away with degrees by the time we get to calculus. So radians are what we want. Okay, so what do I know though? Well, if I did this and I said, okay, I'm going to do a full revolution. Well, what's a full revolution? If I started over here in the east and I went all the way around and came all the way back over, well, that's 360 degrees. Again, the Babylonians thought that was how many days there were in a year. So I'm going to say this. That's what I know. My circumference is 2 pi r, and to do a full lap is 360 degrees. Okay, but wait a second. This brilliant scientist way back several thousand years ago said my radius was 1. Okay, well, let's sub that in. Let's simplify. 360 degrees is equal to 2 pi. And there it is. There is how we're going to convert from degrees to radians. Right there. So it all comes back to the circumference of a circle. I want you to know that because at some point you're going to forget that. And you want to know where these formulae come from. You want to be able to create them. So 360 degrees is equal to 2 pi, and I'm going to say rads, short for radians. I always want to keep units in here. Now, well, what I notice I can do is I can divide both sides by 2. Sure, I'm going to do that. And I'm even going to write 1 there. I know we normally don't, but I like to. That's it. There's your conversion. 180 degrees is equal to 1 pi radians. That's it. That's what I need to know. This is a know me. I'm going to use it the rest of my time in trigonometry and if I get to calculus next semester. So how does this work then? How do I utilize this formula? Well, actually quite simply. Let's convert. Let's convert the following. I don't know. Let's say we have something easy. 30 degrees. All right. Well, I want to convert this into radians. Well, I'm going to do how I do unit analysis when I'm in science class. I'm going to multiply by a ratio. And the unit I'm trying to get rid of will go in the bottom, and the unit that I want will go in the top. So radians will go on the top, degrees will go on the bottom. Okay, let's go back to our ratio that we just created. 180 degrees is equal to 1 pi. Now, our units, degrees and degrees, they're gonzo. I'm going to put this just like this. When I multiply again, fractions, numerator of numerator, denominator of denominator, I'm going to keep my units there. This is radians. And now I want to simplify this. Well, 30 over 180 simplifies to 1 over 6 pi rads. There it is. 30 degrees is pi over 6 radians. Done. That again is this angle that we've traveled right here on our arc. So 30 degrees is about here. That's this right there. That's how far you've gone. 30 degrees is pi over 6 radians. Not so bad, is it? Now, a lot of the time when you're working with the textbook or the workbook, whatever it is you're using, they won't write this radians here, which bothers me. They'll write it like this. It's acceptable, apparently, that if we say we have a pi here, we assume you're in radians. Would you make this old math teacher happy and always write radians, pretty please? Units are important. Okay, let's try that again. So let's convert, I don't know, let's go 225 degrees. Sure. So again, how I set this up is I say the units I'm trying to get rid of go in my denominator. The units I'm trying to keep go in my numerator. I remember this. And if I don't, I create it. And those two units will go away. They'll cancel. What do I have left? 225 pi over 180 radians. Now, I want to simplify this. Friends, I'm going to put this in my calculator. But what I'm not going to do is I'm not going to put the pi in my calculator. Pi is an irrational number. So what I'm going to do is I'm going to put that in my calculator, just the 225 and the 180. 225 over 180 is 5 over 4. So now I still have pi. So I slip it back right there. And units. 5 pi over 4 radians. There it is. Now, the other thing that's going to complicate matters here, not only am I introducing a new unit of measurement, radians, we are going to be doing a lot of work with fractions. Please practice fractions in your head, adding, subtracting, multiplying, dividing them. The more we can do it just in our minds, instead of picking up our calculator, it's going to help you. Trust me. Okay, let's go the other way around. Radians to degrees. And then we're done. So let's just go radians to degrees. So most radians will be expressed as a fraction, an exact value. That's what this is, an exact value. That's another big deal that I'll ramble on about in a different video. We don't like rounding things in math. Rounding is bad. Okay, let's convert this to degrees. Well, all I say is I want to get rid of my radians. I want degrees. Well, 180 degrees is equal to 1 pi radian. My units I don't like, gonzo. What do I have? Multiply numerator with numerator. Do you see the pi's also divide out? Do you see that? The pi's divide out. And there we are. And I can do that in my head. 180 divided by 6 is 30. 30 times 7 is 210 degrees. 7 pi over 6 radians is 210 degrees. That's it, my friends. I could introduce negatives here. What does that mean? Well, a negative would mean that I'm rotating backwards on our circle. So this would be us going backwards, right? We're going the opposite direction of the sun. That's why we call it negative. Doesn't affect how we do this. So I want to get rid of radians. Radians go in the denominator. Degrees go in the numerator. 180 over pi. And pi divide out. Radians and radians. Gonzo. What do we have? Negative 180 over 6. That's negative 30 degrees. We've gone backwards, negative 30 degrees. That's it. Now, I want to do just one last one with you. I just said a moment ago, I really don't like rounding. I like exact values. That's what these radian measures are. However, on occasion, we will come across a question where it will still need to be rounded. Okay, so I say this. We are going to convert 2.3 radians to degrees. This one bothers students when they see it on a quiz, usually the first time. So let's take care of this right now so it doesn't bother you. What bothers them is that they don't see the pi here. They say 2.3 rads and they go, where did the pi go? Well, that means the pi is worked into that number, 2.3. So when I'm doing my work, I still write my units here. So this is 1 pi over 180 degrees. Nothing changes. I'm going to do the same thing here as I did the previous two examples, but the only thing I need you to be aware of is in the previous two, I said the pi and the pi divide out. Well, not in this case, because I don't see another pi to divide it out. So I'm going to go 2.3, the radians will divide out, right? Times 180 over pi. And now I need to stick this in my calculator. I can't do that in my head. And I'm always going to use my pi button, right? Never round that. And so this is approximately 132 degrees. Usually, my friends, we round degrees to the nearest whole, but I really need you looking for that in the question, especially if it's numeric response. That's it, friends. That is how you convert from degrees to radians. So know where our conversion came from, that our conversion really came from a circle, and that should be a 1 there, and that if the Babylonians thought that there was 360 days in a year and our radius is 1, there's our conversion. Okay, hope that helped. See you next time.